to see that there are many classes and types of forklifts or powered industrial trucks. There's everything from the common sit-down type to the narrow aisle stand-up type, and from order pickers to powered pallet jacks. They may be powered by electricity, LP gas, diesel fuel, or gasoline. Some are approved for use in certain hazardous conditions, and some aren't. There's a forklift for just about any job you can imagine. If you've operated a forklift before, you know they're not like automobiles. For one thing, they steer with the rear wheels, the exact opposite of most vehicles, and a concept that can take new operators some getting used to. Because they steer from the rear, forklifts can turn a much tighter circle than a car. And while forklifts may seem like they can turn on a dime, they're not known for their maneuverability. Anyone who expects them to stop or swerve as easily as a car is in for a rude awakening. Forklifts can also weigh 2 or 3 times more than a car. Makes sense, right? Forklifts carry heavy loads in the front, so to balance the load, they have a counterweight over the rear tires to prevent them from tipping forward. And speaking of balance, every forklift operator needs to constantly think about keeping their unit from tipping. A forklift works on essentially the same principle as a teeter-totter. The weight of the load on the forks must be counterbalanced by the weight of the forklift body. Simple enough. But how do you know how much of a load your forklift can handle? The primary source of this information can be found on the forklift's nameplate, also known as a data plate, capacity plate, or ID plate. The nameplate will state the capacity of the forklift. In other words, the manufacturer's guideline for how much weight the forklift can safely lift. For example, this nameplate indicates that the forklift's capacity is 5,000 pounds at a 24-inch load center to a maximum height of 130 inches. Exceeding this capacity can cause the unit to tip. The capacity data on the nameplate is critical information, but it was calculated using a load with a specific load center, commonly 24 inches. So unless every load you intend to lift has a load center of 24 inches, or whatever load center your truck was rated at, and is placed perfectly on your forks, you have to remember that the actual capacity will be reduced. The same thing goes for attachments, which also typically reduce capacity. When necessary, check with your supervisor to figure out the capacity of your unit to handle oversized or irregularly shaped loads. The teeter-totter concept shows how a forklift balances itself on both ends. But there's more to a forklift's stability than that. You also need to be aware of 2 other concepts: center of gravity and the stability triangle. The center of gravity is the point within an object where all the weight is concentrated. The center of gravity is in the center of a symmetrical load, but is off-center in an irregular load. When a forklift isn't carrying a load, you only need to consider the forklift's own center of gravity, usually somewhere near the middle of the unit. But when you're lifting or carrying a load, you have to consider the combined center of gravity of the forklift and the load. The forklift will be stable as long as the combined center of gravity stays within what is known as the stability triangle. Just what is the stability triangle? Forklifts use a 3-point suspension system that runs along an imaginary line between the 2 front tires and the center of the rear axle. This means that even though the vehicle has 4 wheels, it's only supported at these 3 points, the points that form the stability triangle. So when we put center of gravity and the stability triangle together, you can see that the combined center of gravity has to be within the stability triangle in order for a forklift to be stable. It might help to imagine a line running straight up and down through the combined center of gravity. To remain stable, the bottom of this line of action has to be inside the stability triangle. Many factors can impact whether or not the combined center of gravity remains within the stability triangle. The load size, position, and weight distribution critically affect the forklift's capacity and the stability of the unit. In addition, the dynamic forces created when the unit is moving, braking, cornering, lifting, tilting, and lowering loads are important stability considerations. It's up to you to know the load capacity of the unit you drive, as well as the weight and dimensions of any load you carry. Having said all that, you need to be familiar with the rest of the information on the nameplate, as well as the operator's manual and any warning labels, so you have all the facts you need to operate that particular unit safely.
Most people I train don't realize how much, especially if they're new, don't realize how much force and how much weight a forklift actually has. In most cases, they weigh more than a car. 3,000 pounds can do some damage.
It is important for an operator to understand the specs of the machine so that they know not only the weight limitations, but as well as the turning radius and the handling of that piece of equipment.
Bottom line, stay within the forklift's rated parameters, and the combined center of gravity will stay within the stability triangle, keeping the unit stable. One more note. The information on the forklift's nameplate was calculated using ideal conditions. If a load is uneven, unbalanced, or off-center on the forks, capacity may be reduced. If you've never operated a forklift, you'll want to get a good feel for the controls before you do it for the first time. These include the forward and reverse directional controls, lift controls, accelerator and brake pedals, and the parking brake. You should get the hang of these quickly with a little practice. Okay, we've covered turning radius, combined center of gravity, the stability triangle, load center, controls. You've got the basic operating concepts.